Supernovas are one of those space words that sound complicated on purpose. Like astronomy looked at the word explosion and decided it needed a more expensive jacket. But the simple version is this: a supernova is what happens when a star explodes. That is it. That is the clean version. The more unsettling version is that some stars spend millions of years looking calm from far away. Then one day their entire life ends in an explosion so bright it can outshine billions of other stars, which is dramatic. But to be fair, if you spent your whole life as a giant burning ball in space, you would probably want a memorable exit too. Now, not every star becomes a supernova. Our sun, for example, is not big enough to explode this way, which sounds comforting until you remember that one day it will still grow so large that it makes Earth extremely unemployed. So the sun is not harmless. It is just not this specific kind of problem. The stars that usually go supernova are much bigger than the sun, and their whole life is basically a fight between two forces. Gravity is trying to crush the star inward, and the energy from the star's core is pushing outward. As long as those two forces balance, the star gets to keep existing. Not peacefully exactly, but existing, which is already more than most things in space can promise. Inside the star, lighter elements are being fused into heavier elements. In normal person language, the star is smashing tiny stuff together to make bigger stuff, and that process releases energy. First it burns hydrogen, then helium, then heavier and heavier elements, almost like it is going through a cosmic snack cabinet and pretending this is a sustainable lifestyle. But eventually, if the star is massive enough, it starts making iron in its core. And iron is where everything becomes a problem. Up until this point, fusing elements help the star make energy. Iron does not. Iron shows up and basically says, I'm not contributing to this group project. So the star's core stops producing enough energy to hold itself up. And once that happens, gravity, which has been waiting the entire time like a debt collector with infinite patience, finally wins. The core collapses inward extremely fast, not over a week, not over a day, in less than a second. A star that has existed for millions of years can have its center give up faster than your phone battery at 2%. Then the outer layers of the star come crashing down. The core gets crushed into something unbelievably dense, and the whole thing rebounds outward in one of the biggest explosions humans have ever observed. That is a supernova. And this is where the scale starts getting disrespectful. For a short time, one dying star can shine brighter than entire regions of a galaxy. The explosion throws material into space at ridiculous speeds, spreading the star's outer layers across the galaxy like the universe just opened a glitter cannon with anger issues. But this is also where supernovas become weirdly important, because they do not just destroy things, they also help build things. A lot of the heavier elements in the universe either get made in stars or blasted into space by events like this. Iron, calcium, nickel, and other ingredients that later become planets, rocks, oceans, buildings, cars, and eventually people who sit online arguing about whether space is fake. Which means, in a very uncomfortable way, part of the reason you exist is because stars exploded before you got here. So if you have ever felt dramatic, just remember you are made from material with a very dramatic family history. But giant stars collapsing are not the only way to get a supernova. There's another kind called a Type 1a supernova, and this one starts with a white dwarf. A white dwarf is basically the leftover core of a dead smaller star. Think of it like a star corpse, except it is extremely dense, still hot, and somehow not done causing problems. If this white dwarf has another star nearby, it can start stealing material from it. Because even in space, some objects cannot mind their business. As the white dwarf steals more and more, it can reach a point where it becomes unstable, and instead of gently handling that situation, it detonates. The whole thing blows apart. No leftover core, no quiet ending, and just one dead star taking itself completely off the board. Now here's the part that sounds boring for about 2 seconds, and then suddenly becomes insane. These Type 1a supernovas are extremely useful to scientists because they can act like cosmic measuring tools. Not because scientists fly out there with a tape measure. Although at this point, I would not put it past them to try. The idea is simpler than that. Some of these explosions are similar enough that scientists can estimate how bright they should actually be. So when one appears very dim from Earth, that means it is extremely far away. If it appears brighter, it is closer. It is kind of like seeing headlights on a dark road. You cannot touch the car, you cannot walk over to it, but based on how bright the lights look, you can tell something about how far away it is. Except in this case, the headlights are a star exploding, the road is the universe, and everyone involved needs better hobbies. This became a huge deal because scientists use these exploding stars to measure distances across space. And while doing that, they discovered something even stranger. The universe is not just expanding, the expansion is speeding up, which is exactly the kind of sentence that makes you want to close the science tab and go look at something relaxing, like a video of a raccoon washing grapes. But that is the power of supernovas. A star dies in another galaxy, the light travels for millions or billions of years, reaches our telescopes, and then humans use that light to figure out the universe is stretching faster than expected. That is ridiculous. That is like receiving a message from a burning building across the ocean and somehow using it to measure the size of the planet. And scientists can learn even more from the light itself. When they split the light apart, they can see what elements were in the explosion, almost like the star left behind a glowing receipt. Hydrogen, silicon, iron, and other elements all leave clues. So a supernova is not just a flash in the sky. It is a crime scene, a measuring stick, a recycling event, and a warning label all at once. Now, thankfully, Earth is not currently sitting next to a star that is expected to supernova and ruin everyone's week. A supernova would have to be very close to seriously damage our atmosphere, and space is extremely large, which is one of the few times that space being inconveniently huge actually helps us. But even from far away, supernovas are unsettling because they remind us that stars are not permanent. They look peaceful because they are distant. Up close, some of them are giant, unstable furnaces barely holding themselves together. And when they finally lose that fight, they can leave behind some of the strangest objects in the universe, like neutron stars, which are so dense that a spoonful of their material would weigh an absolutely stupid amount, or black holes, which are what happens when gravity wins so hard that physics starts speaking in riddles. So the simple version is this. A supernova happens when a star reaches the point where it can no longer stay stable. Either a massive star's core collapses under gravity, or a dead white dwarf steals too much material and detonates. The explosion is bright, violent, enormous, and strangely useful. It can destroy everything nearby, scatter the ingredients for future planets, help scientists measure distances across the universe, and reveal that space itself is expanding faster than expected. Which means a supernova is not just a star dying. It is a star dying so loudly that billions of years later, tiny creatures on a small planet can look at the leftover light and learn something about the entire universe. And honestly, if you are going to explode, that is a pretty strong final contribution.